So how we perceive real world object is how we want to program them. So if I am programming a book, the book is my object. Now I need to figure out what are the properties of the book. For example, the book has a property called price. The book has a property called ISBN. The book has a property called title. The book has a property called author. The book has some properties that now need to be fed into the class as book properties. And then I should be able to either read those properties and be able to change those properties. When I want to read those properties, Java call those kind of methods getters. If I want to change the values of those properties, Java calls that mutators or setters. Setters and getters. Setters to change the value of the properties of an object, and getters to get the value of those properties. Does that make sense to all of you so far? Okay, so let's create an object called book. Okay, so we'll have a book object. Like sometimes it shows, sometimes it just goes crazy. That's how Zoom works. Okay, so Java. So I'm creating a book. So let me right click on the source to create a new class. The name of the class is book with a public static void main. This is where I will list the properties. Now the properties can be categorized as static and non-static. Those are the two different kinds of properties. The static properties are those properties that can change, that will be same for all instances of class. And if change for all instances of class. Now comes a very important question. What is an instance? An instance is a variable. An instance is a variable, or in other words, an object of class type. Okay. So comes the next question. Why would you want to have static entities? Static entities could be things like counting the number of instances currently running in the memory of the same type. So every time I create an instance, I increment the count by 1. And whatever the count is, it is the same for all the instances. Because if 5 instances are running, the count is 5. If 4 instances are running, the count is 4. So it is the same for all the instances. Such properties that can change, but if they change for everybody, they're called static properties. Non-static are those properties that will not be the same for all instances of a class. And if change, only the instance on which the change took place will reflect the change. For example, going back to our examples, if we have 5 robots all on the move, right? 5 robots all on the move at varying speed. If I change the speed of robot 1, I don't want the other 4 robots to have a change of speed. I want them to still be running at their own speed. So such a property has to be non-static, that it will only affect one object and will not affect the others. Does that make sense? Static versus non-static to all of you? Okay. So now if I am creating an object called book, the property title, should this be static or non-static? Title of the book. Non-static, very good. Why? Because if I declare it as static, then all the books will have the same title, right? I don't want that to happen. Okay. If all books have the same title, there's no point of having so many books. So that kills the whole purpose. How about the property called price? Will that be static or non-static? Price. Non-static. Why? Because I want to have a different price for each book. Very good. Okay, so you got the point. Now let's start working with these. Private, because I do not want anybody to be able to access the property without coming through the proper channel, which is getters and setters. So I will be declaring them as private. So private integer it is getting information from the property of an object.
Okay.
Okay.
So that would, making it private is like the first line of like security.
It is basically you are hiding the properties from direct access.
Okay.
So then you want everybody to come to the properties of an object through the methods.
All right. And then say there were specific people that you wanted to allow to get to the methods. And then there were people that
you cannot set user level permissions here. It's not networking.
Okay.
Okay. Okay. Now, after you're done with this, now comes the question that, okay, I will have multiple books. How will the Java differentiate between title and price of book one from the title and price of another book? The answer is very simple. Let me first write the code and then I'll start explaining to you. For example, in the main method, I write book one equals to new book. And then I write book two equals to new book. So I have two objects of type book. So what this will do, it will create one memory block for book one and another memory block for book two. Each one of them have their own memory blocks. Each memory block will comprise of two compartments. Why two compartments? Because there are two non-static properties. That's why each one of them will receive two compartments. So when I say book one, and I call the special method of book called constructor, it will create one box for the title and one box for the price. One box for the title and one box for the price. So this is the memory for book one, and this is the memory for book two. So if the book one says, I want the title, so guess what? It will grab the title, and this is the price, okay? So if the book one says, I want the title, it will gonna grab the title from book one. If book two says, I want the title, it will grab the title from the book one's memory. So depending on who is calling, the setters and the getters will work in the on the memory of that calling object. Does that make sense to you guys? So the object will decide whenever it calls a setter or a getter as to in whose memory you're grabbing the information from. So let me clear this out altogether. Okay. So now let's say if I write here, book one dot set price to $70.99. So what I'm doing is I'm telling the Java to go to the memory of book one, call the set price method, and set the price for book one only to $70.99. And how does it know to change the value of price? Because that is the value I'm passing to P, and that's the value P is assigning to price. Okay, now let's test this. Book one price. So we'll say book one dot get price. So set price to change the price and get price to get the price. Okay, and to make sure that only book one has changed and book two has not, we will now also display the book two price. Okay. So let's run this program and you will see that the book one's price is $70.99, but the book two's price is 0 because we never changed it. We never set it. So that's how the non-static work in contrast to static. Does that make sense to you guys?
There's one thing that I'm confused about.
Mm-hmm.
So there is the book one equals new book.
Mm-hmm.
Where does book come from?
This book or this book? Which book?
The first one.
This is the name of my class.
Oh.
So I'm creating an object of book type. It's just like when you create an object of string type or the object of scanner type, I'm creating an object of my local class type.
So the class isn't an object, but it has properties.
Class isn't an object. Class basically in real world, in general speaking, you will call it an object, but in Java, you will call it a class. And book one and book two will be called objects of book type.
Okay.
Okay. So when we talk about in Java, you will say book one is an object of class book. Book two is also an object of class book. And objects are also called instant. And when they change, they only change for the object that is changing them and remain whatever they are for the other objects, whatever they are before. Now, when we talk about the second object, the second occurrence of book, because of the parentheses, it is a special function. This function is called constructor. Constructor is that function of a class which lets the object initialize the properties with some initial values other than the default. Right now, the default value for price is 0. You saw that already. When I did not set the price for the book 2, it defaulted to 0. Since I did not set the title for either of the two books, they're both set to null. Let's work with the constructor next. So here, I'm coding a constructor, which is a method of class to initialize instance properties to values other than default. So public book. Constructors always have the same name as the class name, book. I will set the price of a book to, let's say, $50. Okay. Now let's run this program. And you will see that the book 2 is now default to $50. it's not 0 anymore. So constructor lets you initialize the properties to some initial value other than the default for the data type. So similarly, I will be declaring my title property and also assigning it some initial value, like programming book. So that's the default initial value. And then in my output, in the main method, so let me first give you guys enough time to add that line, and then I'll go down to the main and we will test how these initial values come into play. And you can always assign them, override them with some other values. So again, please give me a thumbs up so that I know that you're done with your constructor so I can go down. So now let's scroll down to using the constructors. So we see that because of the constructor, we now do not have the book price set to 0, which is now 2 now. So we're going to now say book 1 title. So when we run this, you will see that both books have the same title, which is the default value, the value before change. Now, right here, I can say book2.setTitle to Python programming. And let's rerun the program. And you will now see that only book 2's title will change to Python programming.